are about to be on. Twitch.tv/Mr. D Burke. Twitch is just so clean, you know. You know what's scary? Am I live? Yes, I'm live. I'm just going to share this out. Nope, I want to go to the Twitters. Twitter.com. Live on Twitch. Writing. NLP. Code. Or, no, we'll go, how about we go using TensorFlow to build an NLP model to make reading medical abstracts easier. Skimlet. Come and say hi, because that's what we're doing. Skimlet, and then we'll get some emojis in here. Fire. Why not? And then I'm just going to copy, paste that. That'll do. Done. Oh, I like this tweet. If you're reading this, breathe deeply into your stomach and exhale through the mouth. Do this 4 times, you feel better. I like that one. I'm gonna like that one. And then we'll go to the Discord. Send it to my boy Ashik. And we'll go to email. Live on Twitch. Milestone Project 2 of the TensorFlow course. All right, we're on. Ashik. Yo, coming. Awesome. Should be here soon. Oh, what's up, my bro? How you doing? Good to see you. Why is my session not telling me how long I've streamed for? Doesn't matter. Everything working fine, Ashik. You can hear me, you can see me. Twitch is not updating for some reason. But that doesn't matter. As long as you can hear me, you can see me. So, what we're doing, we're cleaning up yesterday's notebook to make abstracts more readable. So if we have a big block of text like this, right, how can we use NLP to turn it into something like this to make it more readable? See how this is structured on the left? This is broken down into some headings. And this is just a big paragraph of mess, right? You could read through that, but it's a little bit harder to read through than something like this. So I'm going to put that over there. And what do we have to do? Can we make our data loaders more efficient? One hot for TensorFlow. Does the code run? Yes, it does. So we need to go back through TKs and fix them up. Add text for creating data loaders. Why do we do what we've done? And fix them up. Add TKs for slides to make. Beautiful. Thank you, Ashik. Everything is perfect. We've got the go-ahead from my resident moderator. So if you want the code for this, it's on the TensorFlow GitHub. The code we're going to be writing, Skimlet, it's this notebook here. So I'll put it in there. Code we're writing. We're just going to be iterating on that notebook. And what GitHub notification do I have? Someone's asked a question. Renuga. No worries. Okay, done. Beautiful. So let's get into it straight away. Why wait around? TK. So let's just go. We're going to go through this notebook basically top to bottom again. And I'm going to add the TKs for the what to cover and whatnot. That can come later. But as long as we can run all the code and it makes sense, so we're just going to read through it and make sure everything makes sense. What I might do as well is clone the data locally. I should probably do that. So that way I have a copy of this data locally. ls cd desktop. It's a beautiful day outside today. I'm going to go for a big walk this afternoon. Big walk, enjoying nature. And then cd TensorFlow course, ls. Oh no, I've got a folder called data. What's in here? Okay. So I'm also going to git clone, because the data we get is from GitHub. Some folders here. Now, this is from a beautiful paper called, the paper we're replicating actually, PubMed 200K RCT, a data set for sequential sentence classification and medical abstracts. So big shout out to Frank Denoncourt. Thank you very much. But I'm going to copy this data locally so that if something happens to the GitHub repo, I've got a copy of the data. Comma AI is recruiting engineers. Oh, we're hiring. Who are we looking for? People who've done well at math competitions. Oh, that's a good idea. You know what? I was thinking of taking like a year off and just working on a project and math. That's it. Open source projects. Very smart. Software engineering, senior full stack engineer. iOS and Android, interface designer, ML engineer, fluent in Python. You work on our automatic ground truthing. Oh, that's awesome. Experience with training models. They use PyTorch at Comma AI now. Yeah, that could be a thing actually. I just take some time off, make videos. After the course, I got a lot of plans. Internship. The best way, there we go, the best way to get an internship is to submit good PRs on our GitHub. And then look, he wrote a blog post about it. This is a cool blog. What's it made with? Ruby? Hugo. Oh, a personal private auto completion tool. Very cool blog. What's OKRs? This is very cool. Okay, I'm going to have a look at this later because I need to write some code. But I'm also going to take a post of this. Because I like this. This is how I would hire people. Can save that for later. Math competitions. Yeah, they like people from math competitions. Okay. So if we've got the data locally, yes we do. Now let's, boom. So this is why I need to finish up this course and then work on a project to upskill myself. So you should get some data over here. Yes, we do. Now this, when they use the in the PubMed 20K dataset. So start by using get all the file names in the target directory. I want to start clearing house of some code. Okay, we've downloaded some text data. Do you think we're ready to model it? Wait, we've downloaded the data, but we haven't even looked at it yet. So we need this, a pre-processing function. Wonderful. Reading the lines from a training text file. Oh, thank you, Chris. OKR is objective and key results. I like that. To set yourself objectives and key results. How do I set myself one for today? It was my main focus for today. Stream plus finish notebook 09 ready for recording. Look at this. This is just the universe conspiring. The patterns of our lives reveal us. Our habits measure us. Yes. The actions that you commit every day. Reading the lines from the training text file. The role of each sentence is prefixed. So this, I'm proofreading my own writing here. Different abstracts are separated by abstract IDs, lines beginning with. Yeah. So this is an abstract ID. This is a label. And the tab is what separates the /T is what separates the label from the actual text. Beautiful. Knowing this, looks like we've got a couple of steps to do to get our samples ready. So we need to write a function that takes a target file of abstract samples, read the lines in the target file. For each line in the target file, if the line begins with a triple hash mark, this is the abstract ID, right? Keep count of the number of lines in a sample because that's going to come in helpful later on. If the line begins with a new line mark, mark it as the end of the abstract sample. So new line indicates, so if we looked at the first 20, we'd have abstract 1, and then this is the start of abstract 2. Plus a little more of the next one. All right. Return all of the lines in a target text file as a list of dictionaries in the target text file. Where is it? In the target text file as a list of dictionaries containing the key value pairs, line number, the position of the line in the abstract, e.g. 3. A single line from an abstract. Yeah, so then we've got some pre-processing code here, which just basically gets a list of all the lines from the file name. Then we loop through each line in the target file. If the line starts with, so this is a beautiful Python inbuilt method here. Line starts with, this is a string method. Abstract ID equals line, abstract lines. We reset the abstract string because it's the start of a new abstract. Else is line.isSpace. Check to see if line is a new line. So isSpace will check for new lines. So if we go Python isSpace, why isn't the Python docs like the first thing you find? Run. True. Yeah, and we could do this by just doing it here as well. Python text equals boom, and then text dot is space true, right? So that's actually pretty cool. Clear. Go back. Yeah, so this is just a pre-processing function to get our data ready. And then we create a dictionary, line data, create an empty dict to store data from the line. Why do we get it in dictionary form? Well, because I found in previous projects that a list of dictionaries is actually quite intuitive Python data format or data structure. There might be a better way to store these things, but for me, a list of dictionaries is straightforward. And then else, if the above conditions aren't fulfilled, the line contains a labeled sequence, abstract lines plus equals line. Beautiful. It's one good looking function. Let's use it to pre-process. So it actually works pretty fast because it's only using pure Python methods. What's the error here? Oh, did I not define it? Yeah, so it works pretty fast. Look at this. There we go. Now, so that's a beautiful thing. We've taken a sample that looks like this, and now we've got it in a structured format. So this is again a big shout out to Frank Denoncourt for creating such a thing. Dataset. And then this is the benefit of putting it into a list of dictionaries, is we can turn it into a data frame to make it more visual. Do we have to put it in a data frame? Of course not. But again, if we're using a notebook, we might as well get visual, hey? Now data is in data frame form. We can get a few quick stats about it. Yeah, because this will allow us to do some data analysis. Wow, I'm kind of unpacking the reason why we're doing all of these things as we go. That's the benefit of having it in a data frame, is to give us some quick access to data analysis. We can perform some data analysis on it. Objective has the least amount of labels. So yeah, this is where we could have also created some weights for this. So if we go len train samples, and then how would we quickly, what's a function that we could quickly work out the ratios of all of these? What if we get value count 0? What comes back from that? Value counts to list, maybe? Yeah, so how would we work out the formula of that? I've got an idea. So this is where we could adjust our counts equals counts. And then we can create a list, ratios equals for count in counts. No, we want len train samples divided by count. Is that going to give us ratios? No. How do we get the ratio again? Is it count divided by? No, I want to know how many times. This is just such a simple formula. What's the ratio? Siobhan says to normalize. We don't need to normalize just yet. Ratios. Value over sum of values. Yeah, I got it the wrong way around, didn't I? Boom. There we go. Okay, you're right. Thank you. Now, do we need this? Because we could put this in under class weights. Class weights. Oh, okay. So we could do 1 divided by number value times the total divided by 2. Let's take something like that. So we actually want to change this to class weights. What does this come out to? 1 divided by count times len train samples. That's just what we had. So yeah, this adjusts the weights a little bit, and they divided it by 2. I wonder if this changes anything. We can find out. We'll make an experiment, hey? We'll try it with our best performing model. So we get a list of the sentences. Thank you for that, Shivans. Make label we can go make numeric labels. We're going to create one hot. We need one hot and label encoded labels. The one hot labels are we could get away with just making one label encoded labels. However, TensorFlow's categorical cross entropy loss function likes to have one hot encoded labels. This will enable us to use label smoothing later on. To one hot encode labels, we'll use. I like TensorFlow's scikit-learn's one hot encoder. I like TensorFlow's one hot, but scikit-learn's one hot encoder is, I think for me, it's I like to use it more. Yeah, that's just it. Personal preference. And to make to numerically encode labels, we use scikit-learn's one hot encoder and label encoder classes. Now we need one hot encoder, sklearn. We also need label encoder, sklearn. Copy that. And one hot encoder. Could we run an experiment in parallel here? I think that's probably a better idea, right? Is to just run this experiment quickly so we can know fairly fast if class weights actually do anything. Let's do that, hey? We'll run an experiment in parallel. One hot encode labels. So that works well. Beautiful. And we'll get rid of that, because they're just going to be the same thing, aren't they? Well, we'll find out pretty soon, aren't we? Okay. So that's good. Now, I want to run an experiment in parallel here, so I might duplicate this. There's draft number 1. Draft number 2 can come over here. What's everyone up to today? Let's make this a little bit of a social stream, because it is Friday where I live, so we might as well just have a chat, write some code together, chill out. Maybe you could just use me as some ASMR. What does that even mean? ASMR. I've been seeing that everywhere. The best ASMR video I have ever made. Is this just girls making noises? Autonomous sensory meridian response. Am I going to get banned for watching this? Gibby ASMR.
Hello everybody. Welcome back to another ASMR trigger compilation. I busted out my 2 microphones for this because...
What the hell am I watching? I'll give it to her. It sounds alright. Okay. So, I made the mistake the other day of going on the front page of Twitch. Not me personally. I just looked at the front page of Twitch. Twitch.tv. And I saw my reptilian brain got lured into a photo of a girl on here. And she was in a pool riding a horse. And I'm like, yeah, look at this. Hot tub. This is basically live porn. 14.1k viewers. Good Lord. Toxic trash, 18 plus only. We live in an interesting world, friends. Very interesting world. Okay, we're going to run this with class weights. So I really only care about the best performing model with class weights. Agus Coraza, what's happening, my friend? So we're writing code. We're cleaning up notebook number 9 that I'm writing for my TensorFlow course. We're building a natural language processing model to classify medical abstracts. So the goal here, a really easy way to sort of visualize this, is we want to take this big abstract, right? So this big wall of text, build a natural language processing model that can turn it into something like this. So format it into different sections. Background, method, results. And right now we're just writing some code here. You can get all the code on GitHub, by the way. You can see my, where is it? Here we go. Code, a writing number, notebook number 9. So this is the code we're writing here. Yeah, a sheep. Mate, there's that's what I said. I made the mistake yesterday of going on the homepage of Twitch, and I didn't realize that there's this thing called Twitch Girls. And it's literally like porn. Distracting, man. I'm trying to write some code here, and I go to the front page of Twitch, and there's basically 90% naked women just parading in a pool trying on bikinis. Just like, whoa. And they have ridiculous amounts of viewers. So we know what the world is into, right? We're over here building artificial intelligence. And now, is this going to work? Class weights. Now, I think this might need to be a dictionary. Good catch, everyone. Where did that go? Class weights. We need a dic. Okay. So, class weights needs to be 0 or 1. Now, because our labels are 1 hot, does this matter? So let's just turn class weights into class weights. Dic. Hey Jero, good night, my friend. Have a good sleep, dude. Yeah, that's fucking. Can I swear on Twitch? That's very interesting. I would rather take that money instead of shilling it on a girl in a pool. Invest that into Bitcoin, man. Way better spent. Now we need to make a dictionary here. How can I make a list comprehension with just a dictionary? Can I do this with a enumerate? Yeah. For I in enumerate. Watch this list comprehension of the gods. For I in count, and this is going to be a dictionary. Oh, it's not going to be. It's going to have a new dictionary for every one. I don't think this will work. I just want one dictionary. Could I do just a dic comprehension? There's a way to do this, I know it. Zip, Shavans, you're a beast. And then class weights, dic. There we go. Sivan, you're a legend. Thank you, my friend. What would I have done without you? It's just bananas. One day, I saw one girl and she was writing the name of the idiots who send her money on her body. If you give more money, she puts the name on her breast or something like that. Far out, man. Don't chase women, chase excellence. So now we've got a class weights dic, which is what we're going to use here, and then we can pass it to, okay, so this is our experimental notebook. We're getting distracted by women. Not a bad thing, I love women, but it just shows how quickly you can can hijack the brain. We're trying to do one thing here. So we need, for multinomial, naive Bayes likes label encoded labels. We've got a baseline. We're just going to run through this code very quickly because I really just want to compare the multimodal model that we use works the best. So we'll just come right down to where the multimodal model is. So this is the kind of the disadvantage of having a really long notebook, is that if we wanted to run a quick small experiment on something, we would, here we go, we create our model. We're just gonna let that run to there, or actually, we'll run it right down to here. Data set, and then, okay, this is what we need. No, that's actually still not the best model. Our best model is model 5. Staying alive, staying alive. Okay, we made it. Yeah, so this is why we want to use one-hot encoded labels. Categorical cross entropy, it gives us label smoothing. Examples which are really confident get smoothed a little. So that's a regularization parameter. And then put those data sets together. And now we're going to add here class weights. And we want results with label smoothing and class weights. Class weights. Weights per class. So we have a slightly imbalanced classification problem here. So that's why we're using class weights. Dude, that's amazing. Congratulations, Ashik. That's the power of writing online. 145 days. Dude, that's amazing record. Far out. I think you've inspired me to go back to writing every day. Well, I do write every day, just not in public at the moment. Has that already run to where we want? Now, let's try class weights. Is that what the... Ashik, I'm so proud of you, man. Congratulations. That's what I have on my to-do list for today, actually, is to move my no competition blog post to Medium as well. We've already been streaming for 44 minutes. Is that legit? Time just flies when you're having fun. What the hell? That's the power of writing online, my friends. You never know what's going to come. Here's a lesson. Most of my opportunities in the past 5 years, or whenever I started writing online, most of my best opportunities have come from someone finding my work. I partnered with Andre for my Udemy courses and whatnot because he found a blog post that I wrote. So you never know what's going to happen. that's my mentality with creating things online, is you make the deals come to you. So of course you're limited with a number of hours, a number of, like, say, opportunities that you can apply for per day. However, the vast majority of opportunities that are out there, there's no way you could apply for all of them. So one of the benefits of writing online is that opportunities tailored to you that you may have no idea about come to you, because they're specifically trying to find someone like you, and they come there. So that is amazing, Ashik. Siobhan's self-publishing, as in, like, so my website's made with Ghost. I'm actually really happy with Ghost. If I was to make another blog, I would probably go to just something simple like GitHub Pages, Jekyll. I use Ghost for my blog, but yeah, GitHub Pages, simple blog aware, something like this. That would be my tech blog, would probably be GitHub Pages, but I'm really happy with Ghost at the moment. And yes, Ghost, I do pay for Ghost, but I don't mind. It's my business, basically. My website is my business. Where are these models? Why are they taking so long to train? Where are we up to? Okay. We're nearly up to where we need to go. I cannot recommend creating things online enough. Medium, yeah, Medium is also great because, Ashik, look at this. This is what you should actually do. Go to Google Domains or whatever domain registry you want. You can see my domains there. But then we go, I tried to get Big Dogs go to eat.com and just redirect it to my own website. But you try to get your own name. SheikShafi.com. Dude, go and buy a domain close to your name. And then you can go Medium Custom Domains. There you go. Custom domains are back in Medium. There you go, my friend. You can set up mediumashik.com. Okay, so now we see our results. Here's our first experiment of the day. Run one experiment every day. That's a good motto. A minimum of one experiment every day. So now we've got the results. Let's see if class weights adjusts our with label smoothing and class weights. Let's see if class weights, I'm assuming it might help our regularization a little bit. But our model is already not overfitting. So let's see if this works. What? What does the fit? Class weights, what is the proper parameter? Is it just class weight? Class weight, no S. Of course. All right, I'm gonna let this run. I'm gonna go urinate and I'll be back. You know what time it is. ML Fit, baby. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. My legs are a little sore. Oh my gosh. Class weights fucked our model up. I shouldn't swear so much. Maybe that Twitch will ban me. Jesus. That's interesting. Maybe our model generalizes better without class weights. That's interesting. Wow. Maybe our model is over-regularized. That's what I'm guessing here. Deeper on the squats. What, I wasn't going deep enough? I need to see myself in this. How do I see myself? This is not deep enough? I'm going parallel, man. You want me to go ass to grass? My quads are so tender at the moment. I did a bunch of pistol squats yesterday. So my legs are actually... Wow. There is... I think our model might be over-regularized. Now, the fact that we've added in class weights. So let's remove dropout and see what happens, hey? What if we just take dropout out? And I think label smoothing may be counteracting class weights a little bit. DanielBurke.com was taken. So Mr. D. Burke became me. Plus, I'm Mr. D. Burke everywhere now. I think I still rank top for Google. If you search. Oh, my YouTube is now top. If you don't own the front page of Google for your name, do you even exist? No, I'm kidding. Wow, I think class weights is really buckling our model. So what if we canned class weights, canned label smoothing? So I think our model is over-regularized when we add class weights and label smoothing. I've got to get my hand away from my face. Siobhan says, please do a Q&A. I'm due to do a Q&A, aren't I, Siobhan? Kotoro NLP equals natural language processing. So in other words, finding information out of natural language, which could be text, which could be speech, just any language that you imagine. So this is a natural language sentence. So language as a human would write it. So we've turned off label smoothing. And our models are training very fast now because we've optimized our data pipelines. But let's see what happens without label smoothing, but with class weights. I think class weights may be more suited for really imbalanced problems. Like our problem is not overly imbalanced. So this makes sense actually, to the fact that we're using class weights without label smoothing, because I feel like if you use label smoothing and class weights, then it just wrecks your model's ability to generalize. And yeah, we're still not getting anywhere near the results we were getting with just label smoothing. So I feel like class weights is an experiment that we can just ditch for this, and probably works better, unless we haven't built a precision recall curve and stuff like that, but I'm okay with not doing that. We'll come back to our model in a sec, our main notebook. Yeah, Ghost is quite expensive depending on what you want to use it for. If you just want to write, Medium is probably one of the best, or GitHub Pages. I just like Ghost because it provides me with the tools that I need. That sounded like I was shilling Ghost. I'm not really. You can use whatever platform you want. Beautiful. Okay, class weights is getting canned. See you later. We'll get out of that notebook and we'll come back to this one. Class names. Did we get class weights before? I want to get rid of that cell. Because we don't need that. Little experiment. We tried it. We moved on. That's Ashik, what you're doing as well is part of one of my biggest tips for people applying for a job is to start the job before you have it. Like, you're going into a job, like if you want something and you like write a full-blown blog post about what you're doing and how it relates to what they're working on, that's probably above and beyond what people who already work there are doing. Because people, like anyone, if you're a company and someone writes something great about you, it's one of the best things you could use as part of your own marketing. You could share that post. It's like, hey, someone wrote this post about us. So when if you go to my website, mrdberg.com, this is my Learn Machine Learning course page. I need to do one of these for TensorFlow. But look what I have here. I have testimonials from people who love the course. So that's one of the best things you can ever have. Nice and simple landing page. You sign up, you get a community of people who just love it. So if you're making some sort of product or you own some sort of business or something like that and someone writes something good about you, that is firepower for you to go, hey, people, I've got this business and look, other people are liking it. Word of mouth. However, that's what tech nerds don't really get. I've noticed this. Tech nerds are really good at doing the code and engineering and that sort of stuff, but when it comes to, they think everything can be codified. Relationships have yet to be codified. So relationships are still built the tried and true way, as in people stumbling upon your work and learning about you, or just talking to people, or just going, hey, I made this, you might enjoy it, right? Tried and true engineers will be like, no, the thing that you make should speak for itself. And yes, that's one point, but as well, there is still, people like to know about the people they work with. I'm just going through and spell checking and doing a bunch of stuff, so when I publish this, it's not just an absolute train wreck of a notebook. So they use 68,000 tokens in the paper, because we're replicating this paper here. That's what we're really doing. Replicating the results that this paper got. Now, mind you, we're only using a smaller subset of their data set because otherwise, if we train the big model, which can be an extension to this project, it would take far too long for video creation. So the models that I'm training here specifically train in about a minute or so. That's enough time to figure out if your model's working. Renuga, what's going on? Alex, welcome to the stream. Good to see you both. And Siobhan's has a Python meetup soon. Goal is to present at these. Ooh, that'd be really great. So what I would say, my tip for presenting anywhere is to not only present, but also make your stuff digital, right? Because that's the kind of world that we live in. So that was my one criteria when I did the Stanford lecture was, of course I wanted to do the Stanford lecture, but I mean, if I was going to lecture to say 50 students live, there is no way that I'm not recording that and uploading all of the details to YouTube and GitHub and whatnot so that other people can access it. There's absolutely zero way that I'm not doing that. So that was my one criteria. I'll do the lecture, but I have to record it and it gets uploaded to my YouTube channel. You know what? That's what I also need at my own website, is a list of projects, all the projects that I've worked on in one single place. I might do a little bit of website cleaning up this weekend, and I'll write another blog post that I've got in mind. Okay, our embedding layer works. Create data sets as fast as possible. So, one of the most... we've gone through all the trouble of pre-processing our data sets to be used with a machine learning model. However, there are still a few steps we can use to make them work faster with our models. Namely, the TF data API provides, how can we say this? Provides methods which enable faster data loading. For best practices on these, check out the following. For best practices on data loading in TensorFlow, check out the following, and then this can be 2, 1, 2, and then the main steps we'll want to use with our data is to turn it into a pre-fetch data set. Prefetch data set of batches. Doing so will ensure TensorFlow loads our data onto the GPU as fast as possible, in turn leading to faster training time. To create a prefetch data set, a batch prefetch data set, we can use the methods batch and prefetch. The parameter TF data autotune will also allow TensorFlow to determine how data should be, or how much, determine the optimal amount of compute to use to prepare data sets. Oh, that is a beautiful paragraph, ladies and gentlemen. I just clapped really loud again. I know, Ashik, you love hearing the big clap come through. You know, once we find, I also need, so, I just remembered, this is another note that I need to do for the course, is I need to write some sort of page that talks about what's in each of these notebooks. Because what you'll find is, okay, yes, this says TensorFlow fundamentals, but what's covered in each of these? So I need to add some sort of page here that like has this as the heading, number 7, and then the actual things that we cover in them, because we do cover a fair bit of ground in this. We've got these 2 notebooks. We cover a fair bit of, especially in food vision, we covered a lot on data set loading and preloading just to make everything fast. And I'm also thinking about creating a Notion template so that someone can keep track of how far they've gone through the course. And exciting thing, I haven't told anyone this, but I got an email from Notion, like the company, asking if I wanted to make a video about how to use Notion. So that could be cool. But that's pending because I'm just focusing on the TensorFlow course for now, so no partnerships for now. But that's pretty cool. That's one way how you can make opportunities come to you. Just put stuff out there. Notion would like, hey, we saw your work. Do you want to partner with us? And I was like, I would definitely consider that, because I only ever partner with people that products I like and I use myself. So we need TensorFlow tf.data. Everyone, your homework, if you want to upgrade your TensorFlow data pipelines, is to read these 3 docs in depth, especially these 2, tf.data and optimized pipeline performance. So tf.data. The 3060 is phenomenal. It's a great card. Here, because you're on the stream, everyone, you get a gift. I don't usually show people this, but oh, there was my email. I want you to see all of my emails, but I'm not G'ing you up. This is what happens when you create things online. So, how do I actually hide her name? I got an idea. I'll take a screenshot. So I just took a screenshot, and I'm just gonna, because I don't want to, like, it's not my place to share her name, you know? Who's calling this out? This is what things look like. Because you're on the stream, you get to see this. And this will probably be on YouTube later on, but okay. So I've blanked out all of the names in this. But, can you see that? This is what an opportunity reach out looks like. Hey Daniel, someone here from the Notion team. Notion is an all-in-one workspace for notes, tasks, and databases. Love what you're doing over on your channel and thought I'd see if you're interested in potentially partnering with us on a sponsorship. Here are a couple examples from past sponsorship we've partnered on. Chris Yu, I'm not sure who that is, Machaleb, and Ali Abdal. I've seen lots of Ali Abdal's videos actually. So That's pretty cool, right? So that's the power of creating things online, is opportunities like this may come to you. So whether I accept this in the future, I've got a couple of things going on, but we'll see. So that's pretty cool. I'll cancel that. Don't save. That's exciting, Ashik. I'm glad you presentations is key. If your presentation's boring, how are people supposed to watch it? tf.data and optimize. So there we go. And we also want batch and prefetch. TF data batch. Why is my thing so zoomed in? Batch. And prefetch. Oh, I have something else I'm really excited to show you guys. This is cool stuff. Another website I just found. This is why I love the internet. Auto-tune. TF data auto-tune. So, what if I told you there was a newsletter out there that will pay you? So, you might have seen that newsletters recently have been some of them charge, which is okay. I actually don't mind that. If someone was putting out really good work constantly, I don't mind like paying. This is why I like Medium's model, is it's $5 a month and you get unlimited access. So whether you sign up to premium Medium or not, I mean that I'm aware that amount might not be feasible in some parts of the world. However, $5 a month to me, you could go to the local coffee store and buy a $5 coffee, and that would be one day. But Medium, you'd read, people don't understand, you read one book or one good article and that has the power to like change your life. So that is a great investment to me, but I need to share with you this website. I'm really excited about it. I'm probably going to participate in some of these. So look at this, a newsletter that pays you in Bitcoin. Daily Bitcoin bounties for tasks and tutorials. So this is the kind of stuff you get from my stream. Obviously, I'm not behind this. I'm not partnered with this. I just find it's cool. But look at this. So it's only a week old, but if you wanted to learn a programming language, this will give you $100 Bitcoin for completing 3 Elixir problems in exorcism. Now, I found out about this. Look at this. Learn basic Elixir with exorcism. If you do the challenges, you'll get $100 worth of Bitcoin. And exorcism.io is a place to learn programming. It's all free. Python's on here. Maybe that's a future stream. We just go through some of these Python challenges. Look at this. All right. So I'll send you that. But check out 1929.com. We're getting distracted here. But if you sign up, set up a newsletter at your own domain, write about topics like reversing aging, earn 100 Bitcoin. $100 in Bitcoin. Not 100 Bitcoin, $100 worth of Bitcoin. Proof of workout. If you posted a fact that you did a workout, you get $10 in Bitcoin. Go check out this. I'm probably gonna do some of these. Maybe we could do one of these live on stream later. 1729. Check out that. Check out exorcism.io. Some real cool things that I found in the last few days. But we're getting distracted. Let's go here. Turn our data into TensorFlow data sets. And then take the tensor slice data sets and turn them into prefetched batches. So $100 in Bitcoin right now is a lot of money, because Bitcoin will go. Bitcoin. This is not investment advice, by the way. There's a caveat to all this. It may or may not go up, but I have a feeling it will. And if you can build, like, write an art. This is basically saying if you write an article, we'll pay you in Bitcoin. What a world to live in. Okay, beautiful. Now our data sets. Now we've got a prepared data set. No, we'll just can that. Time to build a series of deep models and try and improve upon our baseline. All of our deep models will follow a similar structure. The main component we'll be changing throughout is a layers component, because any modern NLP model requires text to be converted into numbers, converted into an embedding before meaningful patterns can be discovered within. The first model we're going to do is build a convolutional neural network, one-dimensional. Build model, train model, evaluate model. Okay, we've got some slides we need to make there. And then we build our model. Let's get this bigger. Agus Coraza. Yeah, I believe both of those are free. The last two links that I shared are both free. See, that's another thing that I would love to do, is also, how do I say this? I don't want all of my work to be for free, of course, because I need to be paid some way. But I'd like as much as my stuff out there to be as free as possible. However, I do need funds so that I can use those funds to create more. So if your labels are integer form, not one hot, check out those two links and go wild. We'll only use the first, how many batches should we use? The first 10% of batches of the training set. So what's that? 562, about 18,000 samples of the training set, and the first 10% of batches training set to train on, and the first 10% of batches from the validation set to validate on. Note, it's a standard practice in machine learning to test your models on smaller subsets of data first to make sure they work before scaling them to larger amounts of data. You should aim to run many smaller experiments rather than only a handful of large experiments. And since your time is limited, one of the best ways to run smaller experiments is to reduce the amount of data you're working with. 10% of the full data set is usually a good amount as long as it covers a similar distribution. Beautiful. Delete. For faster training time. Siobhan's, great to hear that you're doing intermittent fasting as well. I do, trust me, I've got in mind I need to do more fitness and health videos, but I'm trying to really get this TensorFlow course finished That way I've finished a lot of people are asking me when's it available on Udemy. So I really want to finish this and get it out there and live. So we're back here, fit a model. Renuga, I'm using a Logitech K811. That's my keyboard. I've had it for about 4 or 5 years now, maybe longer. I've had it for a long time. But Logitech K811. I don't think they make it anymore. What is this? That looks like a cool keyboard. I don't like things that light up though. I just like a keyboard that I can use to type. That's it. K811. Alright, we're getting distracted again. Now, brilliant, we've got our first train deep model. If we didn't prefetch our batched data, it would have taken longer. Oh. Are we using a less powerful GPU for this? Tesla T4? Okay. That's alright. Okay, so it took about 54 seconds there. And how long is it taking here? What? Ashik, someone's copying your blogs? That's so strange. But that's also flattering, because it means they like your work. Okay, feature extraction with pre-trained token embeddings. Training on our own embeddings took a little while to run, slowing our experiments down. Since we're moving towards replicating the model architecture in neural networks for joint sentence classification, it mentions they used a pre-trained glove embedding as a way to initialize, that's a typo, initialize their token embeddings. To emulate this, let's see what results we can get with pre-trained the pre-trained universal sentence encoder embeddings from TensorFlow. Note, we could use glove embeddings as per the paper, but since we're working with TensorFlow, we'll use what's available from TensorFlow Hub. Glove embeddings aren't. We'll save using pre-trained glove embeddings as an extension. The model structure will look like this. You'll notice the lack of tokenization layer we've used in a previous model. This is because the universal sentence encoder takes care of tokenization for us. This type of model is called transfer learning, or more specifically, feature extraction transfer learning. Yes. Now, I'm going to put a TK for a slide here. TK slide. Model we're building. USE encoder. Feature extraction model. To download the pre-trained USE into a layer we can use in our model, we can use the hub Keras layer. Yep. We'll keep the pre-trained embeddings frozen by setting trainable equals false and add a trainable couple of layers on the top to tailor the model to our own data. And we download this from TensorFlow Hub, setting trainable equals to false. Now the beautiful thing about this is that now we might actually only print out, say, 30. Len of sentence. Embedded Oh, I have to double index this, don't I? Wonderful. So we take a random sentence, we embed it, and we truncate the output so it's not massive, and then length of sentence embedding. Building and fitting. Ashik, I'm probably going to record this notebook next week. So what I want to do is have 08 and 09. 08's basically ready to go. 09 will be ready to go after this stream. Of course, not fully ready to go because I'll make some slides. So I'll probably, today is Friday. So I'll probably make slides for it on Monday and Tuesday. So slides for 08 on Monday, slides for 09 on Tuesday, and then record 08. I usually record one video per section. So this will have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So this will probably take about 3 days of recording because I can usually do about 10 videos of recording before my brain is a little bit melted. So I'll probably take, the videos for this will probably be done maybe by the end of next week or start of the week after. So yeah, time-wise, it's usually about 10 videos per day if I'm getting a good day of recording in. And the 10 videos are like the videos you see in the course. And you're right, Alex, transfer learning is a lifesaver. Now we're making character embeddings. So where did I get this alphabet string from? Python alphabet string. Python all characters string. I really wish I linked. Google developers. Google has a full-blown Python. Look at this. Google have a full-blown education on Python. Of course they do. Where did I get this list of strings from? I copied it from somewhere. Python string of all keyboard characters. Oh, there we go. Oh, boom. So we can just, this is built into the Python library. I got an idea. Let's create this from first principles, shall we? Import string. get all keyboard characters for char level embedding. So import string. Let's go. We want lowercase equals, no. Alphabet equals string dot ASCII lowercase plus, what else do we need? Plus string dot digits plus alphabet. This can be alphabet Python. Ali Abdal, 100 million total views. That's amazing. That's incredible. He makes some great videos. Yeah, I think Siobhan's, that's probably where I'm going to go next, is rather than, I would like to publish more videos like my recent TensorFlow video, but not maybe 14 hours long, but like a 4-hour long course or something on one specific thing. Hey, we're building this for this. Or I wanted to make a video, I had the idea of Python. So turn this into a video, like a single video. So Python like you mean it. This is a great website. So if you know what I mean, I would turn this into one single video. And that could be like Python, learn Python like you mean it. I think that would be a cool video. So you can check out this website here. So something like that. Or Python for machine learning or something like that. I think that would be a great video because that's, but the more advanced you get into topics, the less people you'll have watching it, if you know what I mean. Because like I feel like once you get to a certain level of developer, you almost just start reading docs and look up blog posts for examples. You're not really watching videos all the time. So to me, I think videos are really great for like beginner friendly stuff because they appeal to lots and lots of people. But then once you sort of get into it, you need to get very specific, and the amount of people who are going to watch certain videos isn't that great. Does that make sense? Plus string punctuation. Like if you imagine how many people want to learn base level Python versus like deploying a TensorFlow model with Docker to AWS, what's the difference in number of people doing that? Okay. I think that's better. Learn something new every day. I didn't know Python could do that. And plus, so two of the big things for me, I think that I would like on my radar to learn would be I want to get really good at Python, because I feel like I would say my Python skills are like maybe 5 or 6 out of 10, but I feel like if I got really, really good at it, then that would improve everything else. So we've got our character level embedding, yes. Yeah, also Siobhan's, I can only really ever make things that I'm like personally interested in. So, because otherwise I'm sort of like just beating a dead horse. Like I made this, I wanted to get really good at TensorFlow, so that's why I'm making this TensorFlow course. And of course, I've got much more to do because TensorFlow is such a massive library. So I think the next thing after this course is I need to put my skills to the test and build a full-blown end-to-end project, like a machine learning powered product. That's where I'm going after this. So that'll be some fun times actually. I'm really looking forward to that. And I'll use the funds from the TensorFlow course to fund the next project, and then I'll make videos and streams about that. Now here's where we get, this is actually a real cool part, is I'm really interested in multimodal modeling. Tomorrow I'm going to record Machine Learning Monthly, and there's a whole bunch of multimodal stuff in that, in the March issue of 2021. So tomorrow I'm going to record and post Machine Learning Monthly, and that's actually a real cool version that just came out, issue. I think this notebook is getting really, really ready to be fully published. On 10% of training and We can do this by creating a tuple as its first input. For example, char embed, which one comes first? Renuga, I don't watch Linus Tech Tips, but my little brother does. He's really interested in that sort of stuff. Mixed precision you're right, is faster to train a model, as well as probably one of the biggest ones you'll do is TensorFlow optimizing data pipelines. We cover two ways to train faster models in section 7, which I've just recorded and is uploading. So I check out that. Section 7, I think, is being edited by our editor at the moment. Train on data set of. The 3060 is a great GPU. NVIDIA 3060. I believe NVIDIA have an event. NVIDIA GTC. So NVIDIA have an event coming up. I've also been asked to attend this event, and because it's going to be digital, right? I've also been asked to make a video on this event. So April 12, so not too far away. But I believe it's going to be at a terrible time for Australia. So 8:30 a.m. is like, I think that's 2 a.m. for me. But the NVIDIA 3060, I think it has 12 gigabytes of performance. So NVIDIA, what GPU do I have? I have a Titan RTX. First Titan RTX. Boom, look at that. But this is still a great GPU. Yeah, the 3060 is a great GPU. This is going to be a dope notebook once it's finished. Ashik, I think I'm allowed to cover that's what I was going to do. I was going to live stream the NVIDIA event. I'll live stream the replay. I think I'm allowed to do that. Because that's what I was telling I think that's the best way to do it. Is, like I could do a live stream recap of NVIDIA's event. And see what stuff relates to AI. I think that'd be fun if we did a Twitch live stream. We could watch it together and then I don't know how you could do the computer audio, like so you could hear it at the same time I'm hearing it. Yeah, I didn't know I could do that either, but I emailed the... Yeah, I think Shivanj, you're right. Shivanj, you've been an incredible help this stream. I really appreciate it. Thank you. Everyone, actually. That's one of the main reasons I stream, is because I get help from the community. Label smoothing. Renuga, my experience, so it really depends on the best transfer learning model for images. So my experience would be Efficientnet for image classification, but it really depends on the type of model you're trying to build. I would say now that the new Resnets are out, so Resnet's revisited, this is probably the new state of the art for, well, not state of the art, but it's faster than Efficientnet. So once these become available as pre-trained models, you probably want to use these, Resnet RS. But for now, I think Efficientnet is still the best pre-trained that's very quick to use. Thank you, Augus Carosa. I really appreciate it. Yeah. I've had a lot of practice with ML, so I'm kind of, if I'm writing code very fast, it's just because I've had a fair bit of practice. I'm still by far not the best. I just enjoy streaming and making videos, so it helps me practice to explain things as well. Understand what I'm doing. Oh, MobileNet v3. That's very cool. What if I were to train a model here on all of the data? How long does that take? And does that influence our results in any way, shape, or form? If you're coding Python every day, you can never go wrong. Practice, practice, practice. All right, I'm going to let this train for a little bit. I'll be back in a second. Who remembers what we got to do? We're fitting a model, so we need to do ML fit. We did squats last time, so we'll do push-ups this time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Woo! Yes, Bella and Seven. They don't live at my house anymore. They're at my parents' place. At the family home. I've got my own place now. Okay. We'll read ahead as our model's training. Okay, so I need to upload a saved model to Google Storage in a second. So let's open Google Storage. Renuga, I live about 5 minutes drive from my parents' house. About 20 minutes walk. Okay, we have to upload. Renuga, GCP will very much vary. I've spent like $400 in a month before, and last month I only spent like $10. So depends what sort of project I'm working on. Plans for Easter, Siobhan. It's my little brother's birthday tomorrow, so I'll probably hang out with him, and we'll get some, Sunday, I'll probably eat some chocolate. Easter Sunday, eat some chocolate, why not? Spend some time with my family. But otherwise, no, my little brother's birthday is tomorrow, so I'll be hanging out with him. So LS, I want to upload this to Google Storage. So GSUtil, I actually forgot it was Good Friday and Easter today. I didn't even realize. So, what are your plans? GS, ZTM. The R needs to come after the CP. Okay, so that's uploading to Google Storage. That's great. How's our model going? Not bad, not bad. Thank you, Ashik. I appreciate that. Oh, thank you, Shabans. I'll tell him. Happy birthday. Paranoid Polaroid. Just scheduled to run GPU code at a less busy time with the good old at command. That's very intuitive. Great idea. You need to upload to Google Storage. Where's my code snippets? Auth and upload model to Google Storage. Beautiful. Renuga, that sounds like a great day. Code, eat, sleep. Don't forget to get a little movement involved in there. ZTM, skimlit. We're uploading some data here. What's my internet speed? Need to make sure that doesn't show my IP, you know. Wow. 100 megabytes per second download. And about 20 megs per second upload. Not bad. So looks like if we train on the whole 20K data set, we're getting a validation accuracy of around 86, maybe 87%. So we get a fairly good boost by training on all the data, but it takes a lot longer. So let's can that. And we'll get our other model back, trained on 10% of the data, which is a lot faster. "14 hours straight with no water or food." Of course, I've done just the food part. I don't think I've done the water. Oh, probably the closest I've got. I can't recall actively trying to do it, but the closest I would have got is when I was preparing for a jiu-jitsu competition and needed to lose some weight. I restrained from food and water for probably around that time. I didn't measure it, but I've never actually gone, you know what, I'm going to fast from water as well as food for an extended period of time. I do just food all the time, but never water and food. But that's what happens during Ramadan, right? No water or food between sunrise and sunset. So once we've trained this model, I'll save it and then upload it to Google Storage. That way people can have access. I actually want to save it. Skimlet can be one word. Ashik, is that only one day or does it go for a while? "30 days, wow. Yeah, Alex, I got caught trying to figure that out too. So now we need to zip. Zip. To me, they're basically the same thing. If you have a good, whatchamacallit, if you have a good gaming PC with a good strong GPU, you can also use that GPU for machine learning. So I need to authenticate my screen. Bring this over here. I don't have any experience algo trading. Detox Mango, what's going on, my friend? Good to see you here. And Abhijit, welcome as well. I just went off screen for a sec because I need to authenticate with a code. See you, Renuga. Have a good day. Detox Mango says, do you think learning algo training and the technical indicators will make me a statistician? What do you mean by technical indicators? And remember, I have zero experience algo trading. And what do you mean by statistician? Okay, I've authenticated. Now let's upload a saved model. GSUtil, copy R. This should be pretty quick. So let's have a look. Do we have data up here? Yes, we do. Download pre-trained model from unzip so I need to delete I'm not a big fan of any type of forecasting whatsoever, because as soon as you learn a little bit about forecasting, you start to realize that basically all models are broken. The events that really matter are the events outside of like 2 or 3 standard deviations. So, which basically means machine learning crumbles outside of those. So like events which are 8 standard deviations outside, sorry, I forgot to delete this. So any type of predictions, I'm not that great a bigger fan of, especially market or whatchamacallit, like predicting the stock market. Like the biggest financial prediction company in the world or something, or one of the biggest, is called 2 Sigma. There's a reason for that. 2 Sigma. What's 2 Sigma mean? 2 standard deviations. So what does 2 Sigma mean? Right? Things that are true 95% of the time are considered 2 Sigma events. So 2 Sigma. Look at this. What the Just show me your website. This is a too fancy website. Too much going on. Just tell me what you do. So 2 Sigma. And it's all based on the Gaussian bell curve. Which, as soon as you go to real life isn't Gaussian. So this is 2 Sigmas, right? Yeah, you can predict things within 2 Sigmas. But as soon as you go, what do the real events that really matter? The real events that are going to change the course of history are like events out here in 8 Sigma, the things you can't predict. So not even COVID was out here. The financial crisis, probably out here. COVID, you could predict. So that's my take on predictions. The best way to invest is time. Build your skill set over time. Avoid large risks. Extremely large risks. So, sorry, let me clarify. You want to take risks, yes, of course, otherwise you'll get nowhere. But, boom, there we go, practice. Do I think Python is best in machine learning? Depends. Python's great. I'm using Python right now. Wonderful. Now let's try to load our model. What? Unzip command line. Oh, D. I forgot the D tag. I believe it was model 5 was our tri-breed. That's so exciting, Renuga. Detox Mango. What do you mean, when are you going to be ready for marketing yourself for machine learning roles? I'd read my article, Daniel Burke Experience. Read this article, Detox Mango. That's all my wisdom. Basically, start the job before you have it. Whatever you want to start doing, just start doing it. Figure out how to do it. Treat that as something, your next skill to learn. I'll download it and load it in using TensorFlow load model. Where's the load model method? We have a little trouble here. All the best, Renuga. Enjoy. So something may be going wrong here with our load model function. Okay, so something's gone wrong here. Okay, so I think when I zipped my model up, Ashik, you've done it again. Is that another paper? Look at all these files. Boom, gone. Okay, now let's resave this model. Ashik just linked to this paper. Trained much faster than state-of-the-art models while being 6.8 times smaller. What the hell? Resnets are back. Now Efficientnets are back. Of course it's from Quokler. What the hell? Oh, I need to read this later. This came out today. Efficientnets are back, baby. Oh my god. Who's AQR? There we go. This will be good. We discuss a variety of beneficial use cases and potential pitfalls for machine learning in asset management and emphasize the importance of economic theory and human expertise for achieving success through financial machine learning. This would probably be a good paper to read. Okay, so now I want to zip. Why don't I just download this? Command line zip. What are the parameters to zip? Zip. Oh, that's what I forgot. I forgot the recursive zip. There we go. Okay, that's what messed me up before. You got to realize as well, detox. Detox Mango, yeah, there's some great results, but they're also, like if you did a random simulation of, say, 1,000 different financial advisors, and you would find that you'd find like a Pareto curve of some got outstanding results, like Jane Street, 200%, and then you'd have a lot more that are in the long tail. So the best results are the ones that go over time, and you'll find that a lot of financial institutions regress towards the mean. So you might have 1 year of outstanding investments, but then other years of you basically you can lose everything in 1 year, if you know what I mean. So a great series of books to read on this would be Inserto by Nassim Taleb. This will probably teach you more about investing or financial. Read this. Inserto. Okay, I was wondering why that was so small. Why didn't this copy over to? Real Python is great. Where's my model? Why isn't this here? Oh, I copied it. Look at that. I copied the model there. What a moron. There we go. So Efficientnets are back. Yo, what's up, Dennis Denya? Oh, thank you. I'm glad you're enjoying the course. This is insane. What the hell? This is insane. Oh, what do we have here? Okay, so I need to delete. I'm getting. I need to read this paper. I need to update. Machine Learning Monthly just came out with the new Resnets, and this comes out. Far out. Oh, I'm done. Okay, we've stuffed up naming our variables, so we need to delete a whole bunch of crap. How do I get rid of this error? And then I need to delete this from Google Storage. Oh, we've just crossed 3 hours. That's a good amount of time. We'll finish off this notebook and then I gotta go read a paper. This Efficientnet paper looks wild. Look at that, latency. What's latency? Transfer learning performance. Optimized with training-aware NAS and model scaling, our Efficientnet v2 significantly outperforms previous models while being much faster and more efficient in parameters. To further speed up in training, we propose an improved method of progressive learning that jointly increases image size and regularization during training. That's really cool. Extensive experiments show Efficientnet v2 achieves strong results on ImageNet. Compared to Efficientnet and more recent works, our Efficientnet v2 trains up to 11 times faster while being 6.8 times smaller. Now, revisiting Resnets came out on the 13th of March from who? Google Brain, UC Berkeley. Now this is also from Google Brain. Were they not talking to each other? This is what I don't get. The code's not even there yet. Alex asks, what's the biggest difference between Efficientnet and Resnet? You're going to have to read the papers because they're beyond me at the moment. There's been a few changes to them. This one was a really good paper. I really liked that. But then it appears that this new paper, Efficientnet v2, has just come out and wiped the floor with a lot of different models. So check out this paper if you want. Abhijit, thank you very much. I appreciate you tuning into the stream. Make this model public. Okay, now we should be good. That's a sheet. That's a great breakdown. If transformers, so I believe, I'm not actually sure what Tesla uses. I think they use Resnet as a backbone, but that might have changed recently. I mean, that talk was from 2018 or something like that. But they probably use the most efficient model that works best on their cameras. I'm pretty sure Comma AI use Efficientnets. Last week, Resnets are back. This week. I'm going to tweet that out later. Let's see if our loaded model works. So I need to save these. TK. Save these under examples so people can access them. Look at this. It doesn't think that I'm here. Colab is asking me if I'm still alive. Okay. I've got a better idea. Could put these into a dictionary. Okay, so a list of dictionaries. Let's do that. We'll format this like JSON. Then we can save this to we can download this as a JSON, and that'll be good. Wait, do we want this as a list of dictionaries? Yeah. So this is very manual, but we could have probably done this in a better way. Doesn't really matter. It's only for 4 abstracts. If we wanted to really scale this up, we'd do something better. Details. Abstracts equals PD. Beautiful. Okay, that looks good. Do I have abs? Yes, I do. Welcome, Gold Sanchez, to the chat. So now let's save this to a JSON. To JSON. Import JSON. Is this how we do it? I need to open a file. JSON dumps. Let's see what this does. No. Python, save file to JSON. open. That's what I want to do. JSON. Yeah, there we go. I was close. With open as write, as file, JSON dumps, example abstracts. Now, what does this look like? Wonderful. Now, can pandas read in a JSON? With open boom, there we go. Okay, so we can save that to JSON. So I'm going to download this. But now we want to NLP equals example abstracts 0 abstract. Change index for a different abstract. Okay, that is beautiful. Beautiful. See what example abstracts look like. Okay, so wherever possible, you should always load in some abstracts pulled from PubMed. I've prepared some abstracts from PubMed RCT papers to try our model on. You can download them from GitHub. So now I'm going to save this example abstracts, Skimlet example abstracts, to CD, ls, CD. I'll just create a new terminal window. CD downloads, ls, move. Oh no, we go copy Skimlet example abstracts.json, and we want to go up the path. So that's downloads, then to main, then to desktop, TensorFlow course, TensorFlow deep learning, extras. Oh, we need double. That's going to be the current working directory. So we need to derp. It's hyphens, not underscores, Daniel. CD. Okay, so now it should be on GitHub. Beautiful. RMR. So we can delete this. We can delete this. We can move this up. Delete. Now we've downloaded some example abstracts. Let's see how one of them goes with our trained model. First, we'll need to parse it using Spacey to turn it from a big chunk of text into sentences. So we'll just try to delete it again. We'll make sure it's gone. Gone. Download. That's what it looks like. That's what it looks like. And then we pass it. Beautiful. That's much better. That's what I've learned with courses. Delete. Make things downloadable. Copy and pasted from PubMed. Okay. That is one hell of a notebook. Gonna get rid of all this. Okay, so today we've done a lot of cleaning up. The code, this is excellent code. Well, not, of course it could be better, but it's pretty clean. Going back through it, we've got a few TKs to remove, add some headings. I'm probably gonna do them off stream, just so not getting redundant in these streams, you know. I like to bring some fun stuff. So next, I'm going to go through and add all the required slides, take out all of the TKs. It's time for me to take a little break. Read JSON. Thank you, Alex. That would have been another great option. I just read it into an object. And I've got to go read that Efficientnet paper, because that seems like we've got a new state of the art there. So, very exciting. But otherwise, I think that's going to be the end of the stream. Thank you all so much for tuning in. I really appreciate it. The next stream will probably be next week sometime, because it is Friday here and I'm going to spend Easter with my family and hang out with my brother. But we are getting very close to putting a bow on this notebook and having it finished. And then I'll make slides for it, and then I'll record videos, and then that'll be 8 and 9 done. Afterwards, we will have TensorFlow time series fundamentals and project in one. So we'll do time series fundamentals and project in one, I believe. Otherwise, the course will start to get too long. So, with that being said, thank you so much for tuning in. I will see you next time. I've got to record Machine Learning Monthly tomorrow, so stay tuned for that. That'll be on my YouTube channel within the next 2 days or so. But keep learning, keep machine learning, keep moving, keep creating. I love you all. Peace. Where do I end this?